Assalamualaikum and hi everyone. My name is Ahmad Shamil bin Saidi. Today I would like to present about history of Malaysia railway system. Malaysian railway system began on June 1, 1885. Initially transported tin, first line 13 km from Port Kuala Sepetang to Taiping Perak. Operated by Malayan Railway now, Kereta Api Tanah Melayu Berhad. This is KTMB. Expansion milestone 1886. Lines to Kuala Lumpur and Port Swettenham, yes, is Port Klang. 1891, line connecting Seremban to Port Dickson and Teluk Anson to Tapah Road. 1896, Federated Malay State Railway created, merging operation of all four lines. Expanded to public with line interconnecting state, West Coast Line connecting Penang and Johor, East Coast Line connecting Gemas and Bahau. For future development, MRT Putrajaya Line, Sungai Buloh, Serdang and Putrajaya. First phase, Kuasa Damansara to Kampung Batu, launched by July 2021. Second phase expected January 2023. Upcoming project, LRT3, MRT3, East Coast Rail Link, ECRL, KL Singapore High Speed Rail HSR, total rail trade will exceed 30,000 km. Rail system important, crucial for economic growth and social prosperity, enhance connectivity, providing economic and social benefit. For railway trade and civil engineering work, we have 4 items. First, we have track alignment and geometry. This is surveying and alignment, curve and gradient. Second, we have substructure and foundation, that is earthwork and foundation design. Third, bridge and tunnel, bridge construction and tunnel. Four, we have track structure and track component and track laying. We go to track alignment. For track alignment and geometry, we have surveying and alignment. Civil engineering conduct detailed survey to determine the optimal alignment of railway track considering factors like topography, land use, and environment impact. For curve and gradient, engineer design curve and gradient to ensure safe, efficiency train operation. Next, we have substructure and foundation. For earthwork, preparing the ground involves extensive earthwork, including excavation, embankment construction, and grading. For foundation design, the track foundation must be stable and durable. For third item, we have bridge and tunnel. For bridge construction, railway track often require bridge to cross rivers, road or valley. Civil engineer design and construct the structure considering load bearing capacity and dynamic forces from train movement. And for tunnels, in mountain or urban area, tunnels are essential for maintaining the track alignment. Tunnel engineering involves geological survey, excavation, and lining to ensure structural integrity. And lastly, we have track structure. For track structure, we have track component and track laying. For track component, civil engineer design the component of the track structure, including rail, sleepers, and fastening. This component must have withstand mechanical stresses and environmental conditions. And lastly, we have track laying. The process of laying track involves precise alignment and leveling, which are critical for safe and smooth train operation. That's all. Thank you.
Assalamualaikum and good day everyone. My name Raja Muhammad Zuhelmi. Excited to talk about the theory of railway track. So, what exactly is a railway track? In a simple term, a railway track consists of two parallel steel rails that guide the wheel of a train. These rails are securely fastened to sleepers, also known as ties, which are embedded in a bed of ballast. The ballast is usually made of crushed stone, providing stability and drainage. The main function of a railway track is to provide a stable and smooth surface of train to travel on, ensuring safe and efficient transportation. This design has been refined over centuries to handle heavy load and high speeds, making it essential for both passenger and freight transport. Railway tracks are more than just a steel and stone. They are the backbone of our rail transport system and bring enabling connectivity and economic growth. Next, let's dive into the theory behind railway tracks. Understanding the theory helps us appreciate the engineering marvel that allow train to operate smoothly and safely. Track geometry involves several critical elements. On horizontal alignment, this refers to the layout of the track in a horizontal plane, including straight section called tangent and curved section. Curves are designed with transition curve and ensure train can smoothly enter and exit them, reducing wear and tear on both the track and the train. Vertical profile. This involves the change in elevation along the track. Gradient or slope need to be managed carefully to maintain train speed and safety. Vertical curve help transition between different gradients smoothly. The cross section of the track includes the gauge, which is the distance between the rails, and the cant or super elevation, which is the tilting of the track and on curve to counteract the centrifugal forces. The material used in railway track are chosen for their durability and strength. On the rails made of a high carbon steel to withstand the enorm- enormous stresses from trains. They are designed to be hard on the surface to resist wear, but tough enough to handle the weight of the train. On the sleeper, these can be made from wood, concrete, or steel. Concrete sleepers are commonly used today because they are durable and require less maintenance. And lastly, ballast. Crushed stone that provide stability, maintain the track position, and help with drainage. Properly packed ballast is crucial for the track longevity. On structural integrity involve precise alignment and regular maintenance. Alignment and leveling the track must be correctly aligned and leveled to ensure smooth and safe train operation. This is achieved using sophisticated surveying equipment and alignment tools. Ballast stamping machine compact the ballast around the sleepers to maintain track geometry. This process is essential for preventing the track from shifting under the weight of passing trains. And welding rails. Modern welding track of, often use continuous welded rails or CWR to reduce joint which can be weak points. Technique like termite welding are used to join rails, seamlessly providing a smoother ride and reducing maintenance needs. And now, let's go explore the different type of railways, each designed for specific purpose and condition. Understanding this type help us to versatile railways system can be. And conventional railways, these are stand railways used worldwide. They are designed for both passenger and freight train and typically have moderate speed. Conventional railways form the backbone of national and regional transportation network, providing essential connectivity. And high-speed railways are engineered for speed exceeding 250 km per hour. They are specialized track geometry with smoother curve and stronger material to handle high speed. Example, example including the Shinkansen in Japan and the TGV in France. High-speed train offer rapid transit between major cities, significantly reducing travel time. And light rail system are trams are typically used with city from shorter distance. They are designed to navigate tighter curve and can operate on shared streets with other traffic. These systems are crucial for urban mobility, providing a convenient and efficient alternative to cars and buses. And lastly, freight railways designed to carry heavy load over long distance. Freight railways are essential for transporting goods and raw materials. They often feature stronger and more durable track to handle the increased weight and are a vital part of the global supply chain. So, to sum up, we've covered the definition of railway tracks, the theory behind their construction, can be different type of railways. Railways track are fascinating blend of engineering and practical design, crucial for efficient and safe transportation. They are integral to our daily life, enabling economic growth and connectivity across region. Thank you for listening. This understanding of railway tracks set the foundation for appreciating the advanced technology and innovation in the railway industry. Now, I like to pass in the next speaker, the next presenter, who will dive deeper into this cutting-edge advancement. Thank you.
Hi everyone, I'm Rizwan. So on this part, we're going to talk about the railway track gauge. So gauge is it made of a two steel that holds that forming the railway track. It holds the wheel of the train, and it comes in the various size. As you can see from the photos on the screen, it has a light gauge, which is a very small. It's only for the 2 feet, 2 feet wide of the train. And the second one is the narrow gauge. It's slightly bigger than the light gauge, and uh, and then we also have a meter gauge, and meter gauge is also called a standard gauge. So this is quite a common, even in Malaysia also you can see this, and this is the one of the first size of the gauge that being used in India last time. So for Malaysia, we use a standard from India. So and also the meter gauge or the standard gauge is also used in it's widely used. It is even in Middle East, in the Europe, in the China also use meter gauge. But there's another one which is bigger than the meter gauge is the broad gauge, and the size is about 1.676 meter for to cater for the bigger train. Okay, we move on to the railway component. Rail track, it consists of a few elements, few components, including the rails itself. It makes of the steel and the sleepers. Sleepers is usually it made of the timber or also made of the concrete, just to support, just to hold the position of the rail. And we also have a ballast. Ballast is made of the crusher run or the aggregate, just to form the level to put the track on it. Next one, we also have a fastener to bind or to hold the track to ensure that it's on the position. Also, we also have the rail joints and well turn out all the switches, and also the signaling system to support the operation of the train, and also the overhead catenary system. This is used for the electrified railway to supply the electricity. Its overhead catenary system is usually, you can see on the trail, it connects to the car, the train itself. And the level crossing or intersection, this is for the train to turn the direction. You can see this from the for the junction area usually. Okay, bridges and tunnel. This is another form of the track, but the component that I mentioned previously, it still has to be on, whether it's on the ground or on the bridge or whether within the tunnel, but the earlier component is still part of it. So the station and platform, this is the ancillary building to support the whole operation of the train, and railway track itself, as I mentioned previously, and also the track bed. So this is some photo for your reference, as all the components that I mentioned previously.
Assalamualaikum, I'm Suraihan bin Madlani. Now I'm going to discuss our case study, which is we have decided to select one of the current project that's being ongoing right now, the electrified double track rail project from Gemas to Johor Bahru. So under this case study, we are going to discuss a bit of project background, types of railway track, the component of railway track, how the construction being conducted throughout of this project. The project of electrified double tracking rail project from Gemas to Johor Bahru marks the final segment of the KTMB network upgrade from single to double track. Upon completion of this project, will link the southernmost part of Peninsular Malaysia to Padang Besar Perlis. The project encompasses 192 kilometers, which is the infrastructure work will include earthwork, ground treatment, drainage, tracks, box covered, and landscaping work and hydroseeding turfing. As shown here is the detail of the project, which is the project name is design, construction, supply, installation, completion, testing, commissioning and maintenance of electrified double track from Gemas to Johor Bahru. The project summary, as you can see here, the implementing agency, Ministry of Transport, asset owner, Railway Asset Corporation, operator, KTMB itself, type of tender, hybrid design and build, procurement method, direct nego, contractor name as shown, and the most important is the contract price is about 8.9 billion ringgit Malaysia, and the completion date based on EOT number 4, 21st of April 2025. Here also shows the project team which involved directly in this project. The objective of this project, first, to provide comfort, high quality and user-friendly rail services. Second, improving the quality of rail infrastructure from Gemas to Johor Bahru. And last but not least, enhancing rail operation safety itself. As shown here, do you know that this project, the route distance is about 192 kilometers. The operational speed of ETS maximum is 140 km per hour. And then the best thing in this project, throughout from Gemas to Johor Bahru, there are 11 ETS station will be constructed, and then this project also have rail track on the elevated rail, 3 places, which is at Pulau Kasar, it's about 0.5 km, Bandar Segamat is about 6 km, and Bandar Kluang is about 3.5 km. The scope of the project, first, constructing 192 kilometers of electrified double railway track, constructing 11 stations along the road, as I mentioned before, constructing electric train depot for both heavy and light maintenance, constructing the land viaduct bridges for elevated railway track, developing electrification and signaling and communication system for the railway track, constructing infrastructure works, which is including earthwork, ground treatment, drainage, tracks, box culvert, and landscaping work, hydroseeding, turfing. And now the detailed cost of the project, which is the total contract sum is 8.9 billion ringgit Malaysia. The most expensive scope is infrastructure and buildings works. It's earn about 3.5 billion. Also show here is the progress of the project as end of 23rd April 2024. The progress is about 96.94%, which is a delay about 0.05% from the target. And now I'm going to discuss about the type of railway track being used in this project. Basically, there are 3 types of rail track. First is straight track or continuously track, curved track, and elevated track. A straight railway track is a section of railroad that is set out in a straight line without any curve or bends. Straight tracks are typically easier and less expensive to construct and maintain compared to curved tracks. They also allow trains to travel at high speed, and there are no sharp turns to slow them down. Straight tracks are essential for long distance travel and high speed transportation, as they provide a smooth and efficient route for trains to travel. Straight tracks also reduce wear and tear on the train wheels and tracks, leading to lower maintenance costs and improved safety. Okay, in terms of safety, straight track provide better visibility for train operators, allowing them to see far ahead and anticipate any obstacle or signal on the track. This will help to reduce the risk of accident and ensures smoother operation. And now I'm going to discuss about curved track. In this project, they will use a curved track, which is this track is a section at railroad that is designed to follow curve rather than being laid out in a straight line. Curved tracks are essential for navigating around obstacles, following the natural contours of the land, and enabling trains to change direction. One of the main challenges in designing and maintaining curved track is ensuring that trains can navigate the curve safely and efficiently. To achieve this, the curvature of the track must be carefully calculated to allow trains to travel at appropriate speed without experiencing excessive lateral forces or discomfort for passengers. In terms of construction and maintenance, curved track require additional attention compared to straight track. The alignment and super elevation of the track must be carefully designed to ensure that trains can navigate the curve smoothly and safely. In this project, they also have elevated rail track, which is an elevated railway track is a type of railway infrastructure where the tracks are built above ground level, typically on an elevated structure such as viaduct bridges or elevated platform. This design allows train to operate on a raised platform separate from other forms of transportation like roads and pedestrian pathway. A crucial component of this project for the elevated railway especially serve multiple purpose and offers various benefits. The key features of the elevated railway track, first, location. The elevated viaduct are planned for several key areas including Segamat, Kluang, Renggam and Sedena. For the structure, these viaducts are designed to support heavy rail traffic with an axle load of 20 tons. For the length and design, while the total project covers 192 kilometers of double track, the elevated sections are strategically placed to navigate through urban areas, reducing the impact on road traffic and urban development. The main railway track arrangement for an elevated railway is a sophisticated engineering endeavor that involves careful planning, design and construction. By elevating the tracks, railway can achieve better integration into urban environment, improve safety and enhance operational efficiency. The success of such project depends on how you address the structure, operational and environmental challenges through advanced engineering and strategic planning.
Assalamualaikum and hi everyone. Today I would like to present about type of railway track for our case study. For railway track, we have three items: straight track, curved track, and lastly elevated rail track. For straight track, a straight roadway is a section of railroad that is laid out in a straight line without any curve or bends. Straight track are essential for long distance travel and high speed transportation as they provide a smooth and efficient road for train to travel. In terms of safety, straight track provide better visibility for train operator, allowing them to see far ahead and anticipate any obstacle or signal on the track. Overall, straight railway track play a crucial role in the efficiency, safety, and performance of railway transportation system. Second, we have curved track. A curved railway track is a section of railroad that is designed to follow a curve rather than being laid out in a straight line. One of the main challenge in designing and monitoring curved track is ensuring that train can navigate the curve safety and efficiency. Curved track are often used in area where the train is hilly or mountain, as they allow train to navigate around obstacle and follow the natural contour of the land. In terms of construction and maintenance, curved track require additional attention compared to a straight track. While curved track present unique challenge, they are essential part of the railway infrastructure, enabling train to navigate compile train and providing flexibility in road planning. Next, we have elevated rail track. In elevated track is a type of railway infrastructure where the tracks are built above ground level, typically on elevated structures such as viaduct, bridges, or elevated platform. Elevated railway tracks are commonly used in urban areas where space is limited or where there is a need to avoid conflict with existing infrastructure. By elevating the track, it is possible to create new railway corridor without need for extensive land acquisition or disruption to existing transportation network. Next, we have component of railway track in our case study. First, we have track, rail, rail joint, sleepers, ballast, fastening, and turnout. We go one by one for this component. First, we have track. The usual track usual track of the two steel rail secure on sleepers so as to keep the rail as the correct distance apart the gauge and capable of supporting weight of train. Second, we have rail. Rail are the long continuous steel beam that form the running surface for train wheel. They are typically made of steel and are laid parallel to each other to create the track. Rail provide a smooth and durable surface for train wheel to travel on. Third, we have rail joint. For rail joint are used to connect individual rail sections together. They allow for expansion and contraction of the rail due to temperature changes and help maintain continually along the length of the track. For sleepers, sleepers are essential horizontal support that hold the rail in place, distribute the load from the rail to underlying ballast. They are typically made of wood, concrete, or slate urate are laid perpendicular to the rail of regular interval along the track. Next, we have ballast. Ballast is a layer of coarse aggregates such as gravel, crushed stone, or slag that is placed beneath the sleepers to provide stability. Drainage and lead distribution. The ballast help to secure the track, maintain proper alignment, and provide a firm foundation for sleepers. Seats fastening. Fastening are the components that secure the rail to the sleeper. This include rail clip, belt, and other fastening system that hold the rail in place while allowing for some degree of disability and movement. Next, we case study for method of construction for underground railway track. We have 9 elements. First, we have site investigation. Second, design and planning. Third, site preparation. Fourth, track formation. Fifth, track laying. Sixth, track adjustment and ballasting. 7. Installation of ancillary system. 8. Quality control and testing. And lastly, we have final commissioning. First, next, we have a method of construction for ground railway track. For this method, we have 9 items. First is site investigation. Second is design and planning. Third, site preparation. Fourth, track formation. Fifth, track laying. Sixth, track adjustment and ballasting. 7. Installation of ancillary system. 8. Quality control and testing. And lastly, we have final commissioning. For first item, site investigation, assess the terrain, identify natural feature, and map the area. Analyze soil and rock type to determine ground stability. Study water flow drainage and potential flooding issue. For detailed survey, conduct borehole soil sampling and lab testing to understand soil properties. Second, design and planning. Design the track layout including curve, gradient, and straight section. Plan the foundation layer to support the track. Design the layer above the subgrade including ballast and subballast. Plan system to manage water and prevent track flooding. Third, site preparation. Clear the tree, shrub, and debris from the construction site. Remove topsoil and store it for later use in landscaping. Excavate area and use the material to fill low-lying section to create level track bed. And lastly, compact the subgrade to achieve the desired density and stability. Fourth, we have track formation. Grade and shape the subgrade according to design specification. Apply soil stabilization technique if necessary, such as lime or cement treatment. Lay and compact the subballast layer to provide a stable foundation for the ballast. Spread and compact the ballast layer, ensuring it is evenly distributed and level. Fifth, we have thread laying. Place slippers at the specific interval, align them correctly. Use appropriate fastening to secure slipper to the ballast. Position the rail on the slipper. Secure the rail to the slippers using clip, bolt, or other fastening system. Weld rail joint to create continuous welded rail (CWR) or use bolt joint for shorter section. Six, we have thread adjustment and ballasting. For thread alignment, adjust the thread to achieve the desired alignment. Use tamping machine to pack ballast under slippers, ensuring thread stability. Regulate and profile the ballast to ensure proper drainage and stability. 7. Installation of ancillary system. Install and test signaling system for train control. Set up communication system for operational control and safety. Install overhead line and associate electrical infrastructure. Install track circuit for train detection and signaling. 8. We have quality control and testing. Check alignment, gauge, and elevation against design specification. Perform ultrasonic or other non-destructive tests on rail and weld. Test the track under simulated load to ensure it can handle operational stresses. And lastly, we have final commissioning. Obtain necessary certification from railway authorities. Conduct through safety audit to identify and rectify potential issue. Perform trial run with empty and loaded train to ensure the track is ready for service. And lastly, make any final adjustment based on trial run feedback. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Muhammad Iqbal Amir. I would like to present the chapter 4 of our assignment. This chapter will include the conclusion and future development of this project. Firstly, for the conclusion is the electrified double track project EDTP from Gemas to JB is a transformative project for Malaysia rail infrastructure. After the completion in 2025, the project aims to enhance the connectivity and efficiency of the rail network from northern to the southern regions of the Malaysian Peninsula. The key development including the procurement of new ETS and commuter train set to increase service frequency and capacity along this road. The 195 km electrified double track will integrate with the existing network, providing a seamless rail corridor and expected to boost economic growth, improve travel times, and offer a more efficient transportation option for passengers. Overall, the completion of Gemas JB EDTP will mark a major milestone in modernizing Malaysia's rail system, fostering better regional connectivity and supporting sustainable economic development. The next is the future development. The future development is the electrified double track project EDTP from Gemas to JB is progressing towards completion with an expected operational date in 2025. The project is currently over 90% complete, recovering from delays caused by the COVID-19 pandemic. There are three key future developments for the project include: first, procurement of new train. The Malaysian Transport Ministry is acquiring 10 new set of ETS and 6 set of commuter trains to enhance service frequency along the new Gemas JB line. Second, completion and integration. The 195-kilometer line will complete the double-track electrified network from the northern region of Malaysia to JB, significantly improving connectivity and reducing travel time between this region. And the third is enhancement in passenger service. The new infrastructure aims to boost the capacity and efficiency of rail transport, making it more viable option for passengers travelling between Kuala Lumpur and Johor Bahru. The enhancement include improved facility and increased frequency of service to meet rising demand. That's all from me. Thank you.